So, hello everyone. I am Greg Sarjeant, which I guess we'll reveal on the next slide. We're going to spend a little bit of time today talking about Google Zanzibar. So I'm a developer advocate here at OSO. I somewhat shockingly realized as I was going through this that I've been here about 6 months now. And I've spent a lot of that time kind of familiarizing myself with the space. Some authorization as a service was new to me, as it is new to many, and learning a fair amount about Google Zanzibar and sort of the influence that it has had on this space, and sort of the considerations that went into its design, and I've been giving a lot of thought to which elements of that design work really well at a place like Google, and work really well sort of generally, and which are a little bit more difficult sometimes to contend with if you're outside of a place that has sort of Google's resources to marshal for a problem. And so I thought this would be a good time to sort of talk about that, and talk about some of the things that we've been thinking about at OSO to sort of bring the power of Zanzibar to the rest of us. So a brief sort of overview of what we're going to do or talk about, just to sort of orient us all in the conversation. We will spend a couple of minutes on the sort of typical "what is Google Zanzibar" exercise that any webinar like this goes through. And we'll talk some about the new enemy problem, and why that was such a top of mind concept for the folks at Google who were designing and building Zanzibar, and how that affected the design of Zanzibar. And in particular, we'll spend some time talking about the notion of centralization in Zanzibar, and how that centralization concept has really sort of taken root in the authorization as a service space, if you will. And then once we've talked about that, and some of the benefits of centralization, and some of the pain that can be associated with excessive centralization, we'll talk about some thinking that we've been doing around a more distributed approach to authorization. We'll have a brief demo that I neglected to put on the roadmap, but I will tell you is going to come now, and then we'll open it up to some Q&A. And there'll be time for questions and answers throughout the course of the talk as well, but we'll try to reserve some time at the end. Great. So what in fact is Google Zanzibar? If you're in the authorization as a service space, or if you're interested in this, you've likely heard of Zanzibar. But just sort of for purposes of grounding the conversation, when we have talked about Zanzibar, or at least when I've encountered it internally, it refers to one of a few things. The first one is sort of the obvious one, that it is the centralized authorization service at Google that powers authorization for all of its applications, right? So this is the actual incarnation of Zanzibar that you would interact with if you were at Google and needed authorization to power an app that you were responsible for, right? It is genuinely a very impressive feat of engineering. We've discussed it in those terms at great length internally. We'll go into this in a little bit more detail, but as you can imagine, anything that is providing a centralized authorization solution for an organization and a suite of products at Google scale is going to be a pretty astounding feat of engineering, and that does turn out to be the case. What is relevant to most of us who are outside of Google is this notion of Zanzibar as a reference architecture. So one of the things that Google has provided to the community, pardon me, is a white paper that describes Google Zanzibar in. Am I not sharing my screen?
No screen sharing that I'm seeing.
Remember when I said we were going to get past the awkward Zoom part of the exercise?
Well, that's okay. This is all part of the experience.
Yeah. Okay.
I once did
Simón,
an entire webinar.
y cuando sea eso, güey, pásamelos. Yo los doy de
I
alta.
I once did an entire webinar on mute, but because I was determined not to look at anything in the chat, I didn't know.
Nice.
So
Nice. All right. Fortunately, I just did. You missed a very adorable bear doing a reference architecture as a stack. The other slides were, um, less earth-shaking than this one. Okay, so take two, action. We'll pick up from the reference architecture. So uh, Zanzibar, or Google, has provided in support of Zanzibar. Fortunately, the first thing that you can see is a big URL, a white paper that defines the architecture of Google Zanzibar and the data model, and that in not gory detail, but in enough detail to use it as sort of the inspiration for other systems. And a number of people have done this. Airbnb comes to mind. Some people have built their own internal Zanzibar-like authorization systems, and a number of people have, among which is OSO, have provided authorization as a service platforms that, to greater or lesser degrees, are inspired by Zanzibar. In this white paper, the technical architecture is described in pretty good detail, and in enough detail, again, to allow you to implement something similar if you wanted to. Definitely recommend, if you are interested in this sort of thing, reading the white paper. The considerations that have gone into building a shared authorization service at this scale are pretty fascinating to read about. The performance characteristics of Zanzibar are definitely impressive, and it gives a lot of kind of good motivation for thinking about how to do large scale distributed systems that have to have low latency and are highly available. The other thing that is defined in pretty good detail in the white paper is how Zanzibar models authorization, right? And so there are sort of two components to an authorization model and the application of that model to an authorization decision. The first is encoding or modeling the authorization logic, and that is done in terms of what Google refers to as a namespace in Zanzibar, and the block of code off to the left there is a namespace definition. And you can see it's sort of a declarative language that allows you to define the entities and the relationships between them and all that in your model. And then there's the authorization data, which is needed to actually render a given authorization decision for any specific request. And in Zanzibar, authorization data is expressed in terms of what they call relation tuples. So if you've heard of reback or relationship-based access control, this is an authorization model that is driven by, as you would imagine, the relationships between various entities, who belongs to what team or what document is in what folder, that kind of thing. These relation tuples are the syntax and the format that Google has defined to allow them to define these relations for the entities that are being evaluated in the authorization model. So it's a pretty high level overview of kind of what Zanzibar is and what information is available in the white paper. Again, that paper is certainly authoritative for this information, but I wanted to open this up to some questions if people have kind of additional questions about Zanzibar. And I think I saw a poll flash up. Interested to know if you have read that white paper.
Looks like close to half the audience has and half hasn't. So we've got a good mix of people.
Nice. Very good. Cool. Well, again, for those who haven't, probably didn't commit that URL to memory, but if you just Google Zanzibar white paper, it will take you there pretty directly. And let me see if I missed anything in the chat. Oh, okay, cool. Well, then we will let's move on to the next section. So I mentioned sort of at the beginning that we would talk about the new enemy problem and how that informed the the design and the implementation of Zanzibar. What the new enemy problem is essentially is the case where a person makes a request for some document or some entity, and a stale ACL is applied, or a stale version of the authorization model is applied to that request. And so, I get access to something that I shouldn't have access to, just by virtue of the fact that my request and the authorization model are out of sync, and an old authorization model was applied to my request. This doesn't sound like a tricky problem if we're thinking in terms of sort of monolithic applications, and a case where all of my code and all of my data are in a single place, right? If I change someone's role, I update a role table in a database somewhere, and the next time a request gets made for that, or next time that person makes a request for some data, the updated role is immediately reflected, and they're blocked from the application. So why is this a hard problem? Why was it so top of mind for Google? Well, in the sort of base case monolithic application world, this isn't very complicated, but that's not the world that Google is in, right? Their applications are global. They are being used by people all around the world. But more importantly than that, they're actually served from locations all around the world, right? The applications are distributed, the data is distributed. If I'm making a request in say South America, then it's important that that request be served as locally to me as possible, so that I get a timely response and all that. And so in a scenario where I have sort of all of these applications being served from multiple locations, I have data being sort of globally replicated as it's updated in all these various locations, and I have a lot of different layers of caching to sort of ensure quick responses. This problem gets a little bit more complicated, and maybe we can illustrate it with a pretty simplistic case. Like perhaps we have a manager or an administrator, someone who has the ability to change someone's permissions, and they're operating in, say, Africa, and they go ahead and there's some set of documents perhaps that they don't want to be accessible from Europe anymore, right? So the person goes into the authorization system, and they block this particular folder from people who are in Europe, right? Maybe it's World Cup season, and it's all of the football or soccer team strategies are in this folder, and we don't want them getting overseas. So this person updates the authorization model. That update happens locally on the infrastructure that is hosted in Africa, and then it takes some time to replicate that data over to all of the various database instances around the world. And it may happen that there is someone in Europe who, shortly after that initial change to the authorization model is made, makes a request for that data. And perhaps the data hasn't replicated over to the European region. Perhaps there's a stale cache or something like that. And so when they make that request, the authorization model doesn't yet reflect the current state as was defined by the person who made the change in Africa. And so they get access to this document. This is how that problem can manifest in these sorts of large, globally distributed applications where data needs to be replicated and caches need to be updated and all that. If you don't account for the latency of that replication, you can quickly create these situations where someone has access to data. You can get around this by just always requiring the most up-to-date data to be present in every region before making a request. But then you're having to do things like read across regions, or incur very kind of high latency replication operations as a roadblock to requests, and it's essentially impossible to do that without incurring a big performance hit in your application. So the trick is to sort of balance this need to have a responsive application with this need for strong consistency when both the application data and the authorization model and data are globally distributed and being replicated all the time and cached and all that. So in order to sort of address this problem, I guess there were really two key things that needed to be tackled. The first was Google needed to have a consistent authorization, like a consistent representation of the authorization state at any point in time, right? The sort of prerequisite for being able to do this is to unambiguously be able to say at any time X, this was the global state of the authorization model. The way that Google tackled that was to store everything that has anything to do with authorization in Spanner. And so Spanner is a globally distributed database, operates at massive scales, it can manage all of this authorization data everywhere. But the key sort of mechanism that Spanner provides that sort of enables this strong consistency is a time mechanism called true time. And what true time is essentially is a globally consistent, monotonically increasing timestamp that is always consistent for any operation, for any change in Spanner, regardless of where that change was initiated, right? So for any given instance of Spanner, if I make a change in again in Africa and then I make a change in Europe, those true time timestamps will accurately reflect the order of operations once all the replication and everything is finished, regardless of the fact that they occurred in wildly different parts of the world. So by storing all of this authorization information in Spanner and using this true time timestamp to be sort of the clock for Zanzibar, this allows Google to have a completely consistent understanding of what the authorization model looks like at any given point of time globally, right? Even when some of that data may not have replicated to all servers yet. So that's the first thing that we needed, was a way of saying, like, at time X, this is what the authorization model looked like. The next thing we need is a way to make sure that the clients understand and that the clients know what the authorization time is, and the client operations are also synchronized with with changes to the authorization system. Because remember, like, the Zanzibar is itself a distributed application, and the clients that use Zanzibar are also globally distributed. So how do we ensure that when I'm going to make a client change, I always know what the correct state of the authorization model was, again, when that model is distributed? The way that Google addressed this is with essentially a consistency token that they called Zookies, which is a phenomenal name. And the basic premise of a Zookie is, before I make any sort of change to the state of my application, so we're talking about the application data right now, not the authorization data, I request a Zookie from Zanzibar, essentially ask it, what's the state of the authorization system, of the authorization model that's in effect at this point? Zanzibar returns a Zookie that encodes what is basically the effective timestamp. And then the application is able to say, great, this content change that I'm about to make needs to be associated with this version of the authorization model. Anything that I do from here on out, I need to have an authorization model that is at least this up to date. Right? And so this allows Zanzibar and its clients to agree on what the state of the application model is, without necessarily having to make sure that all data is replicated to all regions before any change is made to any application. Right? Like, most of the time, Zanzibar is able to say, for any given operation, I am up to date enough based on the Zookie that you have provided me. We don't need to do any exotic cross-region calls to update the authorization model. Every now and then, if someone needs very fresh up to the last millisecond data, you incur that cost. But this gives Zanzibar and his clients a way to agree on the state of the authorization model and provide strong consistency without, again, having to have all data everywhere at all times and incur all of that extra latency cost that would require. What this all boils down to is that Zanzibar achieves this notion of strong consistency through a fairly aggressive notion of centralization of authorization. So when we think about a centralized authorization service, it's reasonable. It makes sense. I think most of us would think in terms of like, yeah, it makes sense to like have the policy in a central place rather than scattering it across all my applications. Let's define this policy in Zanzibar, hosted with Zanzibar. It's all in one place. We can reason about it easily. All the applications agree on what the policy is. So having the logic in a centralized authorization system, probably jumps into most of our minds when we think about this. With Zanzibar and Zanzibar-like solutions, you also have all of the authorization data centralized in the system because, again, the state of the authorization data determines the state of the authorization model, and it's the Zanzibar data store that is used to sort of unambiguously define what the authorization state was at a given point in time. So in order for Zanzibar to really have a comprehensive understanding of what authorization looked like at time X, it needs not only the authorization logic, but the authorization data stored in it. So anything that has something to do with authorization lives in Zanzibar. So that was kind of a lot of jumping into details of the white paper. Just pause again for some questions if anyone has anything you'd like to ask. You're curious about. Connor, thank you for linking the white paper. Going once, going twice, going to the next section. Cool. So what kind of jumped out at me as I was really kind of wrapping my head around this model is that if you're going to use Zanzibar, and I should say, like, if you're going to use Zanzibar, you work at Google, right? So like to some extent, the using Zanzibar itself is moot. Like that's what you do if you're at Google. But for models like this that centralize both the logic and the data for authorization, you're doing authorization on their terms, right? And what do I mean by that? Why is that a problem? Well, let's dig in a little bit more into this notion of centralization, and in particular, what we're talking about when we say that you're centralizing authorization data in your system. So one of the things that becomes pretty obvious once you start building these authorization systems is that there's really not a lot of data that is purely authorization data. In fact, I'm on the fence about whether there is even any such thing as authorization data. The data that goes into an authorization decision is really application data that you're using in your application for application functionality, and sometimes it impacts or it affects an authorization decision, right? So there is data like roles and team memberships and stuff like that is basically only ever used for authorization decisions. But the vast majority of this data is really application data, right? And so you start creating this sort of tug of war between your applications and your authorization system when the authorization system demands that any data that affects an authorization decision live in it, right? So just to kind of highlight sort of how this manifests, some of the data that we talk about when we're talking about authorizations, right? We've mentioned roles a bunch. When you have roles like that's something that pretty clearly authorization data makes sense to share it in your authorization system because all of your applications should probably agree on what the roles are and what the different roles mean. You may have roles that are tied to specific resources, and that's a different sort of question. But if you have kind of these viewer, commenter, editor, admin, global application roles, you don't want to have to keep reproducing those in all of your various apps or various services that constitute your app. But you might have authorization rules, authorization decisions that rely on things that look like your org chart, right? Perhaps you're making an HR application and a person is able to approve vacation requests for their direct reports, say. In that kind of a situation, the authorization decision is dependent on your organization's reporting structure. And so in order to be able to determine for a given request whether this manager is able to approve this person's vacation request, the authorization system needs to know whether that person reports to that manager. And so now you're needing to put essentially your org structure into your authorization system. File and folder hierarchies are another pretty common application characteristic that affects authorization decisions, right? It's not uncommon for these hierarchies to have some sort of notion of permission inheritance, where the permissions on a file derive from the permissions of that file's parent folder, right? And so on up the chain. And so if you have this sort of a model where the permissions on one entity depend on the permissions of its parents, then you need that whole hierarchical relationship also defined in your authorization model, right? That's the only way that it can make the decision. So going back to that notion then of authorization data, you sort of end up in this no-win situation where you need all of this data in your application. It doesn't make sense anytime I want to move a folder around, say, or display my folder tree. It doesn't make any sense for me to have to pull that hierarchy out of my authorization system in the name of having a single source of truth for that data. But you also need it in the authorization system because of the way that it's designed. So you end up in a situation where you now have two sources of truth for this data. The application is probably really the place where changes to that data are initiated, but it needs to be replicated over to the authorization system, and it needs to be replicated in whatever the format is that the authorization system requires. And so you get into these situations where you need to build kind of synchronization and replication mechanisms. You need to push data from your application databases, transform it into the authorization system's format, load it up into the authorization system. You want that to be happening in real time as people are making changes, so you don't run into that new enemy problem that we were trying to solve. You need mechanisms to detect drift between the systems and remediate that drift. And so this starts to become a pretty heavy burden, which somewhat defeats the purpose of moving to a centralized authorization system, right? Because one of the key things that we want to accomplish by doing this is to free up our development teams from having to manage all of this authorization code and write all of this authorization code so that they can focus on building the application. But if that comes at the cost of having to build all of this extra logic and apparatus and complexity around keeping those two systems in sync, then you haven't really gained as much as you had hoped by making this sort of a move. So having been in this sort of space for a while, we've started to think a lot about what would it mean instead to build authorization around the application and to enable people to do authorization on the application's terms rather than having to sort of bend the application into the demands of the authorization system. We're not the only ones to have thought of this. There are a couple of different mechanisms that exist today that are sort of a compromise approach here, where you keep your application data with your application, and you keep the shared authorization data with your authorization service, but the authorization service still needs that data at authorization time in order to make the decision, because the centralized service is what's making the decision. So rather than synchronizing those live all the time between the two systems, what you can do instead is at authorization time, just pass the missing application data over to your centralized authorization service, right? And so in OSO, the mechanism for this we call context facts, and it works really well. Basically, it allows you. Oh, sorry, did I just talk over something? Cool. So the mechanism in OSO is called context facts. There are other ways that other people have tackled this thing, but the general premise is basically the same. When I want to authorize a request, I just pass at that time any application data that I'm not storing in the authorization service over to the over to the authorization service so that it has all the information it needs based on its authorization model to make the decision. So this is a good approach, and it works. It particularly works well for the cases where you're authorizing a single request on a single entity, say. But as requests get more complicated and rely on more data, or if you're wanting to do things like generate a list of a bunch of things that someone has permission to view, you start ending up having to get a lot of data out of your application and send it across the wire to your authorization service, and then you're sending these sort of long lists of data back. So as sort of the data that is required to render a given authorization decision grows, this model becomes sort of less tenable because you're incurring a lot of extra network bandwidth, and you're having to do more operations, more queries against your database to marshal all of this data and send it across the wire. So this is an improvement. This definitely allows us at least to tackle the problem of not having to replicate data and keeping data where it needs to be. But we've been thinking about, again, how can we make this sort of even more straightforward for application teams, and we've been working on a hybrid approach to this problem, where not only do you not have to permanently store your application data in your authorization service, but you actually never have to send it to the authorization service. And we've been thinking a lot about what would that look like if you were really able to allow the application side to handle the parts of the authorization decision that it has the data for, and only rely on the centralized service for the shared elements of that operation. And what this sort of boils down to in our heads is that rather than sending the data all the time, we can instruct the centralized authorization service, in this case OSO Cloud. We can tell it which data lives where, and then OSO can evaluate the portion of the authorization decision that relies on data that it contains. We can do that from OSO Cloud, pass a partially evaluated result back to the OSO client, and then the OSO client knows how to query the local database or the application database to complete the authorization decision. We've been kind of kicking around terminology for this. We call it list filtering. I've been starting to say distributed evaluation as one way to consider this, but this is sort of what the model looks like. You have your application data, you have your application, it makes an authorized request, your authorization service partially evaluates it, and then it returns this partially evaluated query back to the application for completion. So that is a fairly abstract, I guess, treatment, and it's one thing to see that on slides, but I think we can probably make it a little bit more real with a brief demo. I will pause here again for questions. Also pause because I have to flip windows around and get the demo set up. So there's a natural breaking point. But yeah, if there are questions, and Angie, I see you had a question, and Sam is following up with you. But yeah, please feel free to ask questions in the chat or ask questions live while I am fumbling around with Windows.
Well, so if you are telling the central system to go look for the data itself, wouldn't you have to authorize that system to know that it can communicate with you and that it's not an attacker itself? I mean, that seems like there's an extra overhead there of additional authorization that your app would need to know about and handle on its own. Unless you're talking about sending the query back as well. This is the query that we think you need to do to find whether or not this user has permission, and you need to run that query. Again, that's another level of overhead.
Yes. So the the second case that you stated there, the returning basically the portion of the query that needs to be evaluated is essentially how the mechanism works. So we are doing that. But yes, there is. I mean, I guess as with any sort of operation of this sort, we do want to make sure that the response you're getting back is actually coming from the system that you trust to provide that response and that sort of thing like that. It is, I think, similar to the concern that you would have with just receiving the authorization response back from OSO Cloud directly, that there's not some sort of man in the middle thing going on, if I'm understanding the question correctly. But yeah, but so yes, so I guess that's sorry. So I'm going to do a demo, Guillermo. Sorry, I got distracted by another question coming in. Anyway, to go, Angie, to go back to your question, like, yes, we do ensure that and please, team, correct me if I get any of this wrong and misrepresent anything, but like you do have to interact. You have to supply an API key and all that sort of thing to interact with OSO Cloud, and we are ensuring on our ends that the response is coming back from OSO Cloud. But yes, definitely,
yeah,
in any sort of situation like this. Sorry, like
to add on to what Greg's saying. So yeah, like exactly. So like the high level understanding is as you described, Angie, right? Like you talk to OSO and OSO says, here's the query you should go and run inside your app to do authorization. And like, yeah, one of the things that we are definitely sort of thinking around is not a huge fan of the idea of us just like arbitrarily running, like returning SQL that you would go and run in your app. And so like, for example, one of the ways we're looking kind of bridging that is, is there a world where you can manage and have control over the sort of the exact SQL fragments that will be run like within inside your app, and also just kind of basically providing a kind of a convenient way for you to sort of to know which of those SQLs to run. Like we kind of ideally we'd like it to be, if you're running SQL, it's running against your database, that's something that would be kind of owned and managed locally by your apps. Because yeah, we don't really want to create that additional like, overhead or boundary or things like that. But really the kind of the value that so the two values that this system provides is like, one, the ability to use as much data as we have managed centrally for stuff that makes them to be central. And then two is kind of the ability to turn potentially a arbitrarily complex set of logic into a much more kind of compact or concise description of what you need to go and run inside your app. And the idea is, yeah, finding a way that we can bridge those so that you get kind of full transparency over what is going to run, and also just maybe just kind of knowing which one to fire when.
Cool.
Go ahead,
Thank you
Greg.
very much, Sam. Appreciate that. Yes. All right. So we have a quick little demo app. This is essentially a Ruby on Rails app that lists some articles that people can see. One of our engineers, Vijay Ramamurthy, put this together. I can't in good conscience take credit for having built this app. Unfortunately, he was unable to make it today, but I will do my best to stand in his stead and do the demo. So you can see here we have a list of articles that are available, and we have a user, Alice, who is logged in, and just sort of by briefly inspecting this list, we can see something looks a little bit awry because we have a couple of documents that look like they belong to Bob and should be private, that Alice has access to. And so if we go over and quick check when I flip the screen like that, is this visible? Are people seeing the VS Code window? And
yep,
cool. Since my earlier blunder, I just want to double check. So looking at this Ruby application, You can see our articles controller is currently, it's just returning all articles. When you go to this endpoint, we need to add authorization to this. There is associated with this a polar file which defines the authorization logic that is in place. So you can see we have this notion of a user, and then we have a couple of resources. We have projects and articles, and we define a relationship between projects and articles. So articles belong to projects, and then we can grant people view permission on a given article if they're an owner of the project that contains the article, or they can view it if the article is public. If we take a look, I have a little OSO Cloud instance running locally behind this. If I get the facts out of OSO Cloud, you can see here, OSO Cloud right now only really knows 2 facts. We've only set up the project owner relationships in OSO Cloud, and this is pretty reasonable. If I kind of switch back here, like you can imagine in an application like this, right? Maybe you have Alice here, you have a user. Maybe they're an owner or belong to tens of projects, and so like storing that data centrally, not a whole lot of overhead. Their role on the projects probably doesn't change all that often. Like that's a decent amount of data to store centrally. But this mapping between articles and projects, you could have a lot more articles per project than this. As the application grows, this could become hundreds, thousands of articles per project, and you need to keep track of all of those relations in the database. If you have some notion of articles moving between projects, you have to keep that up to date. Maybe people change their minds about whether things should be public or private. There's a lot more data at the article level that you would have to keep in sync between the 2 systems. And so we really don't want to have to store that in OSO, right? So we'd like to just store this role information, but in order to add authorization to this, OSO will need to know what the article relationships are. If we look at the migration for the table that stores the article data, you can see that we do store a flag on this table for whether or not an article is public, and we do store the project that owns the article on the article table. So this information does exist in the table that stores articles, and we'd prefer to just keep it there and not send it over to OSO. So in order to add authorization to this, there are a couple of different approaches that we could take. The first would be the fully centralized one that we were talking about before, and in this case, we would just use the oso.list method to render the list of articles that Alice has access to. So we would pass in the current user and ask OSO Cloud for all of the articles that Alice has permission to view. This is the centralized instance where all of that article related authorization data would need to be hosted in OSO Cloud. So this would get the job done, but it's not the approach that we want to take. We could also do the compromise approach, which would be sending context facts over as part of that. And it's the same method. We would still be using oso.list, but we would be supplying an optional 4th argument that provides those context facts. And hopefully this sort of helps to illustrate how this can kind of become cumbersome over time. To provide those facts, we need to get that data from our database. And so we're running queries to determine all of the articles that belong to the various projects and to determine which articles are public. And then we're transforming that data so that it matches the format that we need to send over in the client. And then we can send that list of context facts, all of that data going across the wire over to the authorization system. So this will work, and there are sets of operations for which it works really well. But as you start getting into larger and larger lists, it starts to become kind of cumbersome to pass all this data around. And so the third approach, the approach that we're taking with this list filtering capability, of this sort of distributed evaluation, is to use this new list local method. And so the sort of thing that makes this all work is we define, we have a YAML file that defines for the OSO client for those facts that should be resolved from the local database, how do you resolve them, right? So we tell the client that for has relation facts that associate an article with a project, you should run this query against the articles database, right? And for is public facts on an article, run this select statement against the articles table. So we just tell OSO, the local OSO client, essentially what the query is to run when you encounter this fact that you have to resolve. With that configuration in place, we can then use this list local method, and it has the same arguments as the list method, but we supply just a fourth argument to that, which specifies the column that returns the value that contains the list, essentially, or the identifiers that we want to get back. So having put this in place, if I come back over and and go back to the app, now if I reload the application, first I should save live demos, and then having saved, reload the page, and you can see that those private articles to Bob went away. So we have not yet completed the functionality that would have automatically saved that change for you. Maybe that is on the roadmap somewhere down the line. But assuming that you save the change yourself and use that list local method appropriately, you can see that, again, there's nothing up my sleeve. I'll show the facts. OSO Cloud only knows about the project role associations. All of the rest of that evaluation happened locally without us having to pass data around or get involved in any other kind of synchronization operation. So hopefully that helped kind of make it a little more concrete for you. And at that point, I am done with the webinar. I did not put together a nice sort of concluding slide, but let's imagine there's one there. And I will kind of open it up to more general questions. And yes, as Sam said, if you would like to join us and help collaborate on the design of this feature, we're happy to have you, come join us in Slack. You can set up appointments with our engineers. If I been thinking ahead, I would have copied a link to the Slack, but maybe we can paste that in the chat. But yeah, would love to hear your thoughts and get your insight on what you would like to see out of a feature like this. And Quinn, let me double check. So it's just on a GitHub repository. I am not sure whether that repository is public currently, but I will find out. There is a fair amount of local configuration that you would have to do to set it up.
I think it's fair to say, I'm not sure if those example apps are all currently written to be easily runnable and consumable, but we'd be happy to walk something through it live.
Yes.
And kind of get some live feedback as well would be super helpful for us. I dropped a couple of links in the Zoom chat as well. So like there's the docs page where at the bottom there's a form where you can basically say you're interested in the feature. You can come join us on our community Slack and just ping community. You can even at me directly if you want. Any of those work?
Awesome. Thank you very much, Sam.
Thank you, Greg.
All right.
There's some more questions coming in.
Oh, yes.
That's a great question.
Yes.
So so the question from Ashwin there on how effective would this be for queries involving recursive relationships? So if you have those files and folders hierarchies, for example, and that's in your local application, you want maybe that to happen still in your database. The very, very short answer right now is today we don't support that functionality or just error. Going forwards though, I mean, it's one of the areas where we've put in a lot of work in OSO Cloud itself, and similarly, kind of the problems that Zanzibar solved was to be very good at traversing those recursive relationships, whereas it's not the kind of thing that out of the box, Postgres or something is naturally going to be very good at traversing those recursive relationships. So that's kind of a tricky one, because I think personally I see that being one of the areas where OSO itself can provide a lot of value, is giving you good performance for recursive relationships without needing to do any work on your side. And so I think for us, it's maybe a challenging question of like, do if we support that functionality for running the recursion yourself, it could be a lot easier. You might find it's very hard to actually optimize that and make it performant. And so it's kind of an open question for us, is like, do we want to support that functionality if we think it's just going to lead to people having a lot of pain in how to write it performantly? I think on the other hand, one thing you could do is, if you, for example, created your own like denormalized view of the recursive relationships, right? So you pre-computed, maybe in a view, materialized view, just in a table, you pre-computed those recursive relationships. You could plug that into OSO and say, files have a parent or folder, and at that point, OSO would actually be like agnostic of whether it was a pre-computed recursive relationship or not. And it would kind of allow you basically just to choose the right path implementing that without trying to get guaranteed good performance from a thing that we are kind of building for you. So those are kind of some of the options we're sort of evaluating, is like, no, best practices, put it in OSO. Maybe we'll see if it's like good enough for certain situations, or is there a way that we can kind of give you an easy path to implementing it yourself? And yeah, this is the kind of question, this is the kind of thing why we're looking for design partners and people to work with us on this, because I gave you my like abstract answer for like, any situation, but we're interested in understanding the kinds of problems people have specifically, and how they see those trade-offs play out in their app.
Yeah, so just to clarify, you're saying you could sort of pass the entire ancestor hierarchy into OSO rather than just the parent pointer, basically, and then
yeah, like I think if you computed it such that when Greg was showing the configuration, you could say like the mapping from has relation file parent folder comes from blah, and that blah could be something that you've pre-computed and like flattened yourself by doing that like recursive pointer chasing, by like kind of flattening the recursive structure. In that sense, like I think the same logic could effectively applied, because you could still like inherit permissions and roles from like the parent, and the fact that you've sort of manually like unfolded, like unrolled that recursive structure would be something that OSO would not even need to like know about, and would kind of maybe give you that like nice balance of like, you go and sort of do basically there's like it's a less a smaller or simpler contract for like OSO in your database to manage, and that's kind of what we're after. Like we've seen in the past a lot the challenges of trying to like debugging and optimizing stuff that OSO generates for you. It's kind of a big part of some of the downsides we have with the previous library. And so like, I think one of the things that's really nice about this approach that we're working with now is that it's a very like transparent, like obvious mapping of how we go from like a policy to like the SQL we run. We're just taking like the fragments you run and kind of combining them in ANDs and ORs. It's like not super complex. But if we get into the world of like, we generate recursive CTEs for you and you're trying to understand like how that works, it just becomes that much harder for everybody. So we'd like to avoid that if possible.
Yeah, that makes sense. I mean, the feature looks really good, regardless of the concept of partial evaluation.
Cool. Glad to hear it.
Any last questions? We have a couple of minutes left.
Yeah, just a quick question. As a complete OSO novice, I'm just looking at stuff here and I'm trying to figure out, does it have to be SQL or a query language? Like, could I put in any text there templated and I just want to get that back?
So oh yes, sorry, Sam.
Yeah. I'm gonna take this one.
Yeah.
It's a lot longer vision question, I think. Like it effectively, yes, is like it could be the future. Like so today the feature only supports Postgres directly. There's not really a whole lot of Postgres specific stuff that's going on. So like going from Postgres to like any kind of SQL compatible things, like a short step. But like under the hood, how this kind of works is like so we sort of have this process where we take your policy and take your rules and we kind of like compile it down to this like intermediate representation that says like, here's the data OSO should go and check to know whether this thing is allowed or not, right? We sort of like flatten all the logic into these like just like straight data lookups. You know, Alice must be a member of the organization, the folder belongs to the organization, the file belongs to the folder, and the file is public, whatever it is, right? So those are like 4 data checks that OSO should do. And there's like an intermediate representation for that. So like in traditional OSO Cloud, we take all that and we run it and we return a result. In this new feature, we basically take that like list of like 4 or 5 data checks and we kind of like split it based on runs in OSO, runs in your app. We take that like runs in your app part and we like turn it into SQL in a very similar process to what we run inside OSO Cloud. In the future, though, it is possible that we would take that intermediate representation and we would just return that, because basically what it kind of gives you is a simplified like representation of like your policy logic. Like you must check these 2 or 3 conditions, and so it is possible that like that would be a convenient structure for somebody just to implement their own custom logic on top of. But that's like I think we want to kind of get experience of building a few of these like specific like outputs of them before we kind of like figure out if that intermediate representation is like the right abstraction and the right thing to like expose to people.
Yeah, no, I get it. I'm just thinking for my own use case where we have like a large kind of microservices set up, and really what we're actually trying to avoid is having different contexts of our like multi-context or domain-driven kind of teams from looking into different, one bit going, oh, can I just grab this piece of information from your database? Because I don't want it to go to your database. And really what we want to do is just have like a platform API, and really it's just a query to an API, and we've consolidated really that they should know about the API and that's the bit that they can interface with. But I get it.
Yeah. No, so to play it back, you're thinking that, right, instead of us taking that, like look up this data and go and run SQL, it could be look up this data and go and hit an API, hit an RPC endpoint or something. It's the same kind of idea. Like once you know what things you need to check, you fan out those lookups in whatever way makes sense to you. Yeah, I think that would be like a really cool use case. If you're interested, I'd talk to him more actually and talk about how that might work.
All right. Okay, well, thank you again, everyone. We're at time. There are links in the chat if you would like to set up time to talk or find our community Slack. Love to continue this conversation and really appreciate you all taking some time to hang out with us today. Take care, everyone.
Thanks, Greg. Thanks, everyone.
Thank you, Greg. Thanks all.